Hey guys, and welcome back. In the last lecture, I showed you how to train YOLO v3. Today you're going to be learning how to execute the trained YOLO v3 weights for your own object detector using PyTorch. As you may know, we've already established a base for our PyTorch YOLO v3 in the first lecture, and the results were great. I will also show you how to take the new weights from supervisedly and run the Xbox PlayStation object detector with GPU acceleration. As you can see from this demo, the detector works quite well, considering that we have less than 200 images for each class. If you implemented data augmentation, your results will be much better. I'll show you a video in the following lecture to compare the results of the trained YOLO v3 with and without data augmentation. Okay, so let's get started with deploying our YOLO v3 game console detector. Download the checkpoint weights. Okay, so back on supervisedly, we can check the progress of our training over here under neural networks, tasks, and these three dots over here. Click on chart. Essentially, this graph shows the training loss relative to the number of epochs. What we want to do is hover our mouse over here like this until we find the lowest spot on round numbers. We can even zoom in. So let's go down here to 20. Apply. And now this makes it a bit easier to spot the lowest loss. The lowest we can find right now is around 37 with a loss of 0.07. Okay, go out. Go back here to checkpoints. And let's go down over here to checkpoint 37. We can even give it a name. YOLO v3 console underscore 37 to mark the checkpoint that we're downloading. Click create. It says our model was successful. Okay, so we can see it over here. YOLO v3 console 37. So normally you can find your checkpoints under models. We click these three dots and click upload to supervisedly. Once it has uploaded, then we can proceed to download the weights in the form of a tar file. Let's go back to my models. Click over here and click download. And you can see our YOLO v3 weights download. It's around 235 megabytes in size. PyTorch implementation. While the weights are being downloaded, make sure you open up the folder where you ran PyTorch YOLO in the first lecture. So we'll go over here. My one is here. I saved mine under C YOLO PyTorch v3. Yours will be different. Make sure that you also have a test video to view the output of your detector. I've downloaded this one here, which shows Xbox and PlayStation as well as their controllers. Once the file is downloaded, let's extract it. And you should find three files: the weights file, the CFG or config file, and the config.json file. You should recognize these if you're familiar with YOLO v2 and Darkflow. Okay, first let's rename these two. Rename YOLO v3.cfg. Copy this. And let's rename our weights as well to YOLO v3.weights. And what we can do is we can replace these files in the PyTorch library. Copy that. Paste. The CFG we can put in the CFG folder. Replace. Alternatively, you can just rename the old file to YOLO v3 underscore original. And copy the next one. YOLO v3 weights. Paste. Replace. Okay, and one last thing we can do is open up the config.json file. This one over here in Notepad++. Go all the way to the end. And what we want is our object classes, PlayStation and Xbox. Let's copy this. Go into PyTorch, data. Then we can go into coco.names and then paste in our classes. Just enter them. Delete all the unnecessary bits. Make sure you save. So this is where the class labels are read. I suggest adding in a final class called other, in case you get any index related errors. Okay, so once this is done, okay, make sure you save it. And I think we have everything we need to run the detector. Running the game console detector. Make sure that you have the video that has some Xbox or PlayStation consoles ready. Alternatively, you can run the detector on a webcam and point it at your own console or controller. To run the app, open up Anaconda prompt make sure you activate your Conda environment. Let's cd into our PyTorch directory and use this command over here. Copy. If you're not familiar with this process, please check out the first video of the series to learn how to run this. So you can either use Python or Python 3, depending on what you have. And if all went well with no errors, you should be able to detect if your gaming console is either Xbox or PlayStation. Now just note that with our current dataset, we're still getting incorrect detections, where it will detect the incorrect class, and this is perfectly fine. The way to improve classification of the detector is to increase the amount of data to at least 1000 images per class. Another tip is to label controllers, consoles, and branding separately. This will result in more classes, however, the network will have a better understanding of each object. The final tip is to try out data augmentation. You can get this lecture and advanced YOLO v3 lectures on either Patreon, Udemy, YouTube membership, or Teachable. Okay, so I hope this series has worked well for you. Please leave a comment of what you enjoyed about the series and share with us your object detection applications either here or on Discord. In the next lecture, I'll show you how to add in your confidence level, expressed as a percentage, as well as a comparison between with data augmentation and without. Thank you for watching, and we'll see you in the next lecture.